Today, the internal combustion engine is used in motorcycles, automobiles, boats, trucks, aircraft, ships, heavy-duty machinery and power generators. A four-stroke engine is an internal combustion engine in which the piston completes four separate strokes: intake, compression, power, and exhaust during two separate revolutions of the engine's crankshaft, and one single thermodynamic cycle. Let's take a look at the basic internal parts of a four-stroke engine. Inside the engine block, there is a crankshaft. Piston rods are attached to crankshaft. Pistons are attached to the piston's rods. As the crankshaft turns, it causes the lifter to make each piston move up and down. At the top of the crankshaft there is a camshaft which is connected to the crankshaft by a timing belt. While the crankshaft is making the pistons move up and down, the camshaft is turning, making the valves to open and close. Let's now take a look at how the combustion creates pistons motion. First, intake stroke. The inlet valve is opened, and the fuel-air mixture is drawn in, as the piston travels down. Second, compression stroke. The inlet valve is closed, and the piston travels back up the cylinder, compressing the fuel-air mixture. Just before piston reaches the top of its compression stroke, a spark plug emits a spark, to combust the fuel-air mixture. Third, combustion stroke. The piston is now forced down by the pressure wave of the combustion, of the fuel-air mixture. The engine's power is derived from this cycle. Fourth, exhaust stroke. The exhaust valve is opened, and the piston travels back up, expelling the exhaust gases through the exhaust valve. At the top of the stroke the exhaust valve is closed. This process is repeated. What had been presented is the cycle of operation of one cylinder, of a four-stroke engine. Generally engines have two or more cylinders acting in concert with each other to produce the engine power.
This section examines basic EFI systems. EFI systems use electronically controlled injectors to spray the fuel. There are two basic systems: throttle body injection, also called single point injection, and multi-point injection. Throttle body injection sprays fuel into the air as it passes through to the intake manifold. Multi-point injection has an injector for each cylinder, which sprays fuel directly into the intake valve port. The whole system has a fuel tank to store the fuel, a fuel pump to circulate fuel and provide pressure in the system, a fuel filter to clean the fuel and protect the injectors, a fuel rail or pipe to supply the injectors with fuel, injectors which spray into the intake valve ports, a pressure regulator to control pressure in the system, a throttle body with a throttle valve to control the flow of air to the engine, an air cleaner, ducting and an airflow meter to provide clean measured air, and a plenum chamber or surge chamber to dampen the flow of air. There is also an electronic control unit, a computer that receives data from sensors around the engine. It processes this data and uses the results to operate the injectors.
Modern engine oil. Incredible engineering that enables incredible performance. By lubricating the engine, the oil isn't simply keeping it running smoothly, it's protecting it and preventing damage. Oil begins its journey in the engine's sump, a reservoir of oil. From here, it gets pumped around the engine. The oil pump is vital to the life of the engine. It sucks oil up from the sump through a pickup tube, pressurizes it, and sends it around the entire engine through a circuit of oilways. From the pump, the oil travels to the oil filter, which removes microscopic particles and supplies clean oil to the rest of the engine. Clean oil flows to all the critical engine parts. The bearings, supporting the crankshaft on a continuous film of oil. Pistons, cooled down and kept clean by the oil's detergent action. And the valve train, protected by the oil's anti-wear system. Loads in the valve train are the highest in the engine. This is where the oil experiences the most stress. To avoid friction and damaging wear, these fast-moving metal components must be lubricated. The oil is the only thing preventing metal-to-metal contact. Returning to the sump via oil return channels, the oil completes its journey. This whole journey can take as little as 5 seconds. Throughout the oil's journey, its primary function is to protect. It does this in many ways, reducing friction and metal-to-metal contact, reducing wear throughout the drive, and reducing harmful deposits. Regular maintenance with a quality oil and filter will protect and preserve the heart of the car, the engine, keeping it running at its best for longer. It's more than just oil. It's liquid engineering.
Most diesel fuel injectors use the same basic design, made from heat-treated alloy steel. The actual shape will vary according to the application. The injector assembly has several main parts. The nozzle assembly is made up of a needle and body. A pressure spring and spindle hold the needle on the seat in the nozzle body. A nozzle holder, sometimes called the injector body, may allow for mounting the injector on the engine and some method of adjusting the spring force applied to the needle valve. A cover keeps out dirt and water. The injection pump delivers fuel to the injector. The fuel passes through a drilling in the nozzle body to a chamber above where the needle valve seats in the nozzle assembly. As fuel pressure in the injector gallery rises, it acts on the tapered shoulder of the needle valve, increasing the pressure until it overcomes the force from the spring and lifts the needle valve from its seat. The highly pressurized fuel enters the engine at a high velocity in an atomized spray. As soon as delivery from the pump stops, pressure under the needle tapered shoulder drops, and the spring force pushes the needle down on the seat, cutting off the fuel supply to the engine. Some of the fuel is allowed to leak between the nozzle needle and the body to cool and lubricate the injector. This fuel is collected by the leak-off line and returned to the fuel tank for later use. There are two main types of injector nozzle, hole and pintle. Hole-type nozzles are commonly used in direct injection engines. They can be single-hole or multi-hole, and they operate at very high pressures, up to 200 atmospheres. They give a hard spray which is necessary to penetrate the highly compressed air. The fuel has a high velocity and good atomization, which is desirable in open combustion chamber engines. In pintle-type nozzles, a pin, or pintle, protrudes through a spray hole. The shape of the pintle determines the shape of the spray and the atomization of the spray pattern. Pintle nozzles open at lower pressures than hole-type nozzles. They're used in indirect injection engines, where the fuel has a comparatively short distance to travel and the air is not as compressed as in the main chamber.